Okay, Damaris, yeah, I got your message. Thank you. Uh, how's everyone doing?
Pretty good, pretty good.
So I'm all caught up in my grading. I grade every class. So we will have a quiz this Thursday as I want to say as usual, but it might not be usual. The quiz will cover section 3.5 and 3.6 this Thursday, which is implicit differentiation and logarithmic derivatives of logs, I should say. Today we're going to do section 3.9, which is the next section that we're doing, because if you look at the homework sheet, it jumps from 3.6 to 3.9. By the way, just a heads up, if you hear me and I sound a little different sometimes with some letters that I'm pronouncing, because I have these retainer things in my mouth. I don't know what they're called. Yeah, have you heard of Invisalign? Anyway, my dentist has been bugging me for years. Oh, you should really do this, this, and this. I finally said, all right, here we go. Fine, just shut up and take my money. And so I put these. I go, okay, I just thought I put these on at night. He goes, no, you have to have them all the time. Just when you're eating, you take them out. I went, how long for? 17 weeks. That takes us to the rest of the semester. Anyway, and then I wear something at night. Anyway, which is kind of an issue because you got to take them out, eat, and then put them back. Well, what if I just want to sip on a drink the whole day? Anyway, that's not your problem. It's my problem. Well, you can only drink water. You can't drink carbonated drinks. Like there goes my Coke Zero, or well, I think you're hanging out, or anything with sugar or carbonation or anything. So basically, just water.
Just shotgun it.
Well, braces is different. You put a longer period on, and that's when your teeth can't be fixed, because this is just a quick fix. I mean, if it's just slightly crooked, apparently. Oh yeah, sorry, I'm charging. So yeah, I took it off now. Thank you for reminding me. All right, moving on. So any questions from 3.6?
Could you do number 19 on 3.6?
On 3.6, okay. So take the derivative of y equals the natural log of e to the minus x plus x e to the minus x. So you can't split this up into two logs, remember, because it's not natural log of product. It's already a plus sign in here. So this whole thing that's inside the log right here, this whole thing, oops, this is not what I meant to do. So this whole thing right here, that whole thing is your happy face, so to speak. So the derivative would be what you're taking a log of goes on the bottom. Its derivative goes up top. So what's the derivative of the first term on the bottom? That's this guy. It would be itself times the derivative of the exponent, which would be -1. Plus, what's the derivative of this guy right here? Well, there you got to use the product rule, because you got this guy times this guy. So first times the derivative of the second, which is negative e to the minus x, plus second times the derivative of the first. So once again, this was first times the derivative of the second, plus second times the derivative of the first. So again, it's natural log of something. That yellow is the something. That goes on the bottom, which is what I did here. I put it on the bottom. Its derivative goes up top, which I put on top. Now, as far as simplifying, let's see here. On top, you can, I guess, factor out an e to the minus x. So you're left with a 1 minus x and a plus 1. Well, this works out really nicely, actually. Oh, let me just make sure I didn't make a mistake here. No, it's going to be a negative 1 minus x. Okay. And then on the bottom, you can factor out an e to the minus x. So you're left with a 1 plus x. So these guys cancel out. So we're left with, inside, negative 1 and plus 1 cancel out, negative x over 1 plus x. Is that what the back of the book had?
Let me check.
Yes.
Okay. All right, any other questions?
Could you just do 45 if nobody else has one, too?
45. Y equals x to the sine of x. Now, if you read the directions, it even gives it to you. It says use logarithmic differentiation to find the derivatives of the function. So the guesswork is gone. You take the log of both sides, and that's the natural log, that is. That allows you to use the properties of logs to bring the sine of x downstairs. Now I'll take the derivative of both sides. The derivative of the natural log of y is, well, what you're taking the natural log of goes on the bottom. Its derivative goes up top. On the right side, it's first times the derivative of the second plus second times the derivative of the first. What's the derivative of sine? Cosine. And we're almost done. So multiply both sides by y. So you got y prime is equal to sine of x over x plus natural log of x times cosine of x. This whole thing times y. Now replace y with what y is equal to, which is x to the sine of x. And that's it. We're going to move on here. 3 from 3.6. I didn't even assign that. Oh, I did. Okay, we'll do that. 33. Last one, then I got to move on, and then we can do the rest later. 33. So the question is, find the equation of the tangent line to the curve at the given point. So the equation is the slope of the tangent line. So what's y prime? Well, what you're taking the log of goes on the bottom. Its derivative goes on top. Now let's plug in the x value like you did on the test to see what the slope of the tangent line is. So when you plug in the x value into the derivative, that tells you the slope of the tangent line. So 6 minus 3, which is 3. 9 minus 6, which is 3, plus 1 is 4. So that's slope right here. Now we're going to find the whole equation. So y equals 3/4 x plus b. We know it goes to the point 3, 0 here. So we're going to plug in 3 for x, 0 for y. That's 9/4 plus b. Subtract 9/4 from each side, negative 9/4. So the final answer is y equals 3/4 x minus 9/4. All right, I'm going to start the next section in a minute once you finish writing this down. I have it in my evening class on Monday, Wednesday nights. Is that OCC? I have a student who had to travel to Canada for work. So I don't know if you've heard this in the news, but if you're traveling to Canada, they give you a COVID test right there when you land, and you're basically in their facility for 36 hours until the test results. Now, if it's positive, you're held in a government facility for 14 days. I call it a jail. They call it a government facility. I don't see the difference. Question?
Yeah, Professor. So the answer in the back of the book for this question is 3x minus 9. I think when you did inputted the 3 into the to get the slope, you might have miscalculated it because the slope is supposed to be 3.
Oh yeah, I'm sorry. Yeah, I see it right now. 9 minus 9 is 0 plus 1 is 1. So I don't know why I put 9 minus 6, which is 3. I think I thought of this as a 6. So 9 minus 3 plus 1. Yeah, thank you. Yeah, so this is going to be 3 over 1. So the slope is 3. Thank you. Then the rest is going to be wrong. So then you plug in 3 for x. There's still the yellow right here. You still plug in 3, 0 for so 0 equals 3 times 3 plus b. So b equals negative 9. Did they say y equals 3x minus 9? You said?
Yeah. Yes.
Okay,
Yeah.
okay.
Y equals 3x minus 9.
Oh, okay then. Oh, your hand is still by the way, man. So anyway, you're held at a government facility for 14 days. If you test negative, you still, which that's what her case, she tested negative, but you still have to quarantine in a hotel that they pick for you, and they lock you up in there. By locking you up in there, I mean literally, they will call you. This is what she said on Zoom last night. Like 5 times throughout the day, randomly, to your call your hotel room to make sure you're inside your room. And sometimes they'll send the security up to make sure you're in your room. So she's got to be there for 14 days, 2 weeks, and can't ever step out, do anything. And yeah, so I feel really bad for her. So I said, well, what if you only have to be in Canada for 10 days for work? She goes, nope, minimum 14 days. All right. I'm going to assume no, not pay for the room because it's for her work that she has to go. So I'm assuming the company pays for it. But now if you were traveling, let's say you wanted to go visit your, I don't know, your mom lives in Canada and you want to go visit your mom. And 14 days that before you can go to their house. I don't know.
Last train of thought.
No, I'm saying, no, I just don't know. $3.9 related rates. And so this section, we're going to do some word problems so you can see how derivatives are used. But before we get to the word problems in this section, I want to just do some basic explanation of how. So remember when you did implicit differentiation and you took the derivative of x, which is 1, because the derivative of x with respect to x is 1. The derivative of y was dy over dx because you're taking the derivative with respect to x. Well, in this section, x and y are going to be get the same treatment because there's going to be a third variable, t, for time. So if I say take the derivative with respect to t, well, what's the derivative of y with respect to t? dy over dt. What's the derivative of x with respect to t? dx over dt. So let's just do a simple example here first. Example 1. So no word problem yet. Just everything is given to you. Let's suppose y equals 2x squared minus 6x. And I'm going to ask you part A. Find dy over dt when x equals 3, given dx over dt equals 2. So let's say all that is given to you. So what I would do, what I'm doing now is in blue. So the black would be provided for you. So since they ask us find dy over dt, that means I'm going to take the derivative with respect to t. What's the derivative of y with respect to t? dy over dt. What's the derivative of, oh, let me write this a little bit better. What's the derivative of 2x squared? It's 4x times the derivative of x. What's the derivative of x? Now, with respect to t, not with respect to x. It's dx over dt. Minus 6x. What's the derivative of 6x? It's, well, minus 6 times the derivative of x, which is dx over dt. So the derivative of y is dy over dt. The derivative of x is dx over dt because we're taking the derivative with respect to t. Why am I taking the derivative with respect to t? Because they said find dy over dt right here, right? All right, now once we do that, we plug in all the values that we know. Well, they said when x equals 3, so I'll plug in 3 for x. Given dx over dt equals 2, so that's 2 minus 6 times 2. So FYY, that's 2, so I just plug those in for that. And x equals 3, so we plug that in for x. So we got 24 minus 12, so the answer is 12. Now, you're probably wondering, well, what does that mean? I'm glad you asked that question. Let's talk about it. So, second here. So you got to just take my word for it. It's going to intersect here and here. So you got a parabola of y equals 2x squared minus 6x. That looks something like that. Now, what that means is we're given at x equals 3, which is like right here. Given dx over dt equals 2, meaning suppose the rate at which the x, the horizontal distance, is changing at, let's say, 2 units per second. That means the vertical distance, dy over dt, is changing at 12 units per second. So in this case, for every 2 units at this particular second moment, when dx over dt is 2, means y is going up at a rate of 12 units per second. Again, at x equals 3.5, it's going to be different, but it's at that particular moment, when x is changing at a rate of, for every 2 units to the right, x goes, y is going to go up 12. That's the rate at which changing at that time. Now, it could be different. At this x value, when x is going, changing to in a positive manner, y would have to be going down. So it's all relative to where you are on that graph. Does that kind of make sense?
I have a quick question.
Yeah,
When you say dx or dy respective to dt, where is the variable t in this equation or in any of the problems? Or are
T
they
is
just going to
time.
be?
T is
Oh,
time.
okay, but in this problem, it has 2x and 6x. Are we just assuming that time is just always there? Because when you say
Well, because
dt,
because the question asks find dy over dt, so that's why you're taking the derivative with respect to t.
oh, I see. So you're just plugging in dy over dt when we're trying to find the derivatives of the variable or for x, because well, it should be y, right? Because it's not dx over dt, it's dy over dt.
I'd like to say yes, but I have no idea what you just asked.
So like when it says find dy over dt, why are we doing it with x when it's supposed to be dy, or is when it's supposed to be y? Am I correct when I say that, or you know what I mean? Because it says find dy, but you put in dx over dt.
Well, it says find dy over dt. So what I decided to do is see this equation that's given to me. I took what I did from here to here is take the derivative of both sides with respect to t. Because what you do to one side, you got to do to the other. So the derivative of y with respect to t is dy dt. The derivative of 2x squared with respect to t is 4x times the derivative of x dx dt.
Oh, I see. Okay, that makes more sense.
Okay, so let's move on. Now let's go. We're still going to continue on with this problem. Go to part B. Is oh, Herday, how are you doing over there?
Doing fine, Professor. How about you?
Not bad. Hold on. Oh, can you move your camera down a little bit? I think I see you. Oh, yes. Yeah. Better lighting this time. Is Aaliyah here today? Oh, there you are, Aaliyah. There you go. Okay.
Hi.
So that was supposed to be part A. Part B. Find dx over dt. Oops. When x equals 1, given dy over dt equals 5. So in this case, okay, same equation, y equals 2x squared minus 6x. So in this case, they want you to find dx dt. You're still going to take the derivative of both sides with respect to t. But now you're finding what dx over dt should be given this information. So we're going to take the derivative of both sides with respect to t. Oh, I missed the chat. Oh, dy over dt. So the derivative of the right side, again, it's 4x times dx dt minus 6 times dx dt. Now, since I got to figure out what dx over dt is, I'm going to factor out the dx over dt. Now, plug in the values that you know. You could divide by 4x minus 6, but I can just plug it in right now. So dy over dt is 5. Dx over dt, 4 times 1 minus 6. That's going to be a negative 2 here. So dx over dt will be 5 over negative 2, negative 5 halves.
Excuse me, Professor. So whenever we see the question is asking to find like a dx over dt, we put the dx over dt next to the x variable, correct? For every x variable? And the
Yeah, because whenever you're taking the derivative of x, it used to be 1, but that's because you were taking the derivative with respect to x. Now you're going to take the derivative with respect to t, so it's dx dt.
okay, thank you.
By the way, to answer your questions on the chat, Brian, you would have to ask me. Well, I think she was the only person, I guess, that had a Canadian passport. So she was the lucky one, quote unquote lucky one to go. I would have just said, I can't go. I literally can't get on a plane right now. We're in a pandemic, can't you see? And we just start freaking out. But of course, if you want to go to Cabo, I'm down. But going to Canada, being locked up in a hotel room for 14 days. It's a pandemic. You can't make me do that.
Or Cancun.
Yeah. They would have to pay me more than double. All right, let's do another one. Yeah, hazard pay, because I'm getting on a plane with possible, maybe I could get sick.
Hangovers don't count, Professor.
No, she said she's a smoker too. She can't even go outside for a cigarette break. So she's locked. I go, why don't you just open the window? She goes, the window's not open. Oh my. I was feeling so bad for her. I don't think it will make her quit. I think she's just gonna binge smoke once that 2 weeks is up. All right. Like, I'm lighting 5 up. I'm putting all 5 cigarettes in my mouth at the same time. Okay, I'm gonna stop talking.
You get super lightheaded that way.
I don't know. I'm just making up. Sorry. All right. Okay. Let me start you off. Y equals I would rewrite this like this. So you don't have to use the quotient rule, but you got to use the chain rule. All right. You guys try to do this. Okay, so so we're taking the derivative with respect to t. Now, why are we taking the derivative with respect to t? Because it says find dy over dt. That's your cue. So dy over dt is equal to power rule, -1 times 1 plus x squared to the -2 power times the derivative of the inside. Can someone tell me what the derivative of 1 plus x squared is?
2x.
Ooh, with respect to t, 2x times dx dt, right? So let's rewrite this as -2x. Let's just do it this way. Hold on. We'll go with -1 over 1 plus x squared times 2x dx dt. Now let's plug in what we know. So we know x is going to be -2. Dx over dt is 2. So you plug all this in. We're going to get -1 over 1 plus 4 is 5 square root of 25 times -8. So negative times a negative is positive. So we get 8 over 25 . So dy over dt is going to be 8 over 25, whatever the units are. Okay, so now let's do some word problems. Now, this is section 3.9. Well, the thing is, when you do word problems, every problem is going to be different. It's not like a factoring question. It's like an algebra, like, all right, here's how you factor, and then you're going to do 50 problems just like it. Or even in this class, when I showed you the power rule, all right, here's how you do the power rule. All right, now go take the derivative of those 50 questions. Every problem is going to be slightly different, and this section will be challenging. So don't get frustrated. It's not like, hey, it's going to be very rare for someone to see every single question and say, oh, yeah, I know how to do that. Boom, 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 done. Next question. Yeah, that's how you do it. You're going to run into a problem. You're going to have to think about it for 5 minutes. Maybe you don't know how to do it. Then you go to the next one. Maybe that one you think about for 5-10 minutes, you know how to do it. Then maybe the next one you don't. Maybe the next 2 you don't. But then that third one after that, you know how to do. You just do what you can. It's a question. These are questions that might be tough for you to do. And you do what you can, and then what will happen is on the word problems, I'll post on Canvas eventually the answer keys so you can see how the word problems are done step by step. The challenge of the word problems is getting the equation, because you got to get some sort of relationship, because you need an equation there so that you can take the derivative. The 2x, that's the derivative of x squared. So the derivative of x squared is 2x times dy or dx. The challenge is getting some sort of relationship so you can get an equation. Now, some problems, it might be a formula for, like, let's say if you're dealing with a rectangle, it's the formula for area of a rectangle. Sometimes it's going to be the Pythagorean theorem, a squared plus b squared equals c squared. Sometimes it might be, whatever you're dealing with. It's a sphere, so the volume of the sphere. Now, in that case, the formula would be provided for you because you might not have the volume of the sphere memorized. All right, so let's go ahead and do question number 4 from the book. I'm on page 249, actually. But you could just write number 4. But if you have your book, turn to page 249. So that way you can read along the book. How many of you need a minute to get your book? Okay, yeah, go ahead. Take your break. It's 1 minute. We'll start. All right, sorry, I zoned out. You guys all got your book? Okay, so number 4, this is page 249. The length of a rectangle is increasing at a rate of 8 centimeters per second, and its width is increasing at a rate of 3 centimeters per second. When the length is 20 centimeters and the width is 10 centimeters, how fast is the area of the rectangle increasing? So let me draw a picture for you. So there's my rectangle. And from what they said, the length is increasing at 8 centimeters per second. So that means dl over dt equals 8 centimeters per second. The width is increasing at 3 centimeters per second. So dw dt equals 3 centimeters per second. So far, so good? And then they ask you, when the length is 20, when L is 20, and when the width is 10, find how fast is the area of the rectangle increasing. So essentially they're asking you to find dA over dt, because that's how fast the area is changing, right? The rate of the dA over dt. So now you need some equation to take the derivative of. Well, in this case, it's going to be area of a rectangle, right? So area equals width times length. So how do I take the derivative here? Well, you got to use the product rule. So I'm going to take the derivative of both sides with respect to t. dA over dt is equal to first times the derivative of the second plus second times the derivative of the first. The derivative of w or L is not 1, right? It's the derivative with respect to t. So the derivative of, so it's first w times the derivative of L, which is dL over dt, plus L times the derivative of the first. What's the derivative of w? dw over dt. All right, now we're going to plug in what we know. What's w? Well, they said when w is 10. What's dL over dt? 8. Plus, what's L? 20. What's dw dt? 3. So you got 80 plus 60, which is 140 square centimeters per second. So after you finish writing this down, I'm going to talk about this a little bit more here. So here's the thing. When you're doing a related rate problem, think of it as you're watching like a 10-second video. What is it called online? Like a GIF? Those are like 3 seconds, right? Well, anyway, imagine you're watching a 10-second video. In this 10-second video, the way it's working is you have a rectangle, and that rectangle is expanding. Oops, that was not the same ratio. But anyway, as you see this rectangle getting larger and larger and larger in this 10-second video that we're watching, and the rate at which this rectangle is getting larger is the length is increasing at 8 centimeters per second, and the width is increasing at 3 centimeters per second through that whole 10-second video that you're watching. Now, the question is, as this length and width of this rectangle that keeps on increasing throughout this video, at the exact moment when the length is 20 and the width is 10, at that particular split second, how fast is the area increasing? And the answer is 140 square centimeters per second. Because I have to tell you at which moment. Because at the moment when the length and the width are maybe less, then the area is not expanding as fast. But so it all depends on a lot of factors, what the length and the width is at that time and what the rate of change for each the width and the width is. So that's why you plug them all in, because it's dependent on all those numbers. Does that kind of make sense? Yeah. So a lot of times now when I call it a 10-second video, it depends on the word problem. Sometimes You're talking about, you'll do one later where the ships are moving, and it might be a 5-hour video that you're watching. Or it could be a 3-second video that you're watching. It all depends on what the word problem is. So let's do another one. So this one that I'm going to do is question number
Professor,
14.
really quick, could you just explain the where you made the equation for this for number 4? Just the equation making part.
Well, it's just area equals width times length. That's the formula for area of a rectangle.
Oh, okay. But you used the product rule here, you said, right? Is
Yeah.
that what you said? Oh, okay.
Addison, is that what it's called, a GIF, when you watch a 10-second video?
Yeah, I think so.
GIF, GIF. All right. Number 14. If a snowball melts so that the surface area decreases at a rate of 1 square centimeters per minute, find the rate at which the diameter decreases when the diameter is 10 centimeters. All right. This is a little bit more challenging. So we got a snowball. So it's 3D, but I can do a circle. But it's a ball, not a circle. Now, you need to know the formula for a surface area of a sphere. So that one, you might not have memorized. I would provide it for you. Surface area, that's S, is equal to 4 pi r squared. So that's the formula for the surface area of a sphere. I would provide that for you. So the question is, so you got to visualize you're watching a video. And this video, this snowball is melting. And the rate at which the snowball is melting is the surface area, the area of the surface of this snowball is decreasing at 1 square centimeter per minute. You're essentially watching paint dry. It's boring. This is a boring video. It's not as fun as the last one. Find the rate at which the diameter is decreasing. So as this ball is getting smaller and smaller and smaller because the snowball is melting, the diameter is going to decrease as well, right? It's related. The diameter is like double the radius. It's the distance from one end to the other through the middle. So how fast? So they're basically asking you how fast is the diameter decreasing. Now, here's the thing. The formula for a surface area of a sphere has radius in it. It doesn't have diameter. So I got to figure out a way to throw the diameter in there because they want to know at which rate is the diameter decreasing. So here's what we're going to do. We're going to let X be the diameter. I'm not going to let D be the diameter because there's already D is for derivative, dW, d theta, dx. I don't want to put dd. So I'm going to let X be the diameter. So if you remember, so then X has to be equal to 2r, right? X is double the radius because the radius is from here to here. That's r. That would be X, the whole thing. So if X equals 2r and I solve for r, r will be 1/2 X, X over 2 or 1/2 X. What else is given to us? Well, we're told that ds over dt equals -1 square centimeters per second. So as I do this problem, I'm going to change my formula for surface area and write it in terms of diameter instead of radius. Because the question is, how fast is the diameter getting smaller? What's the rate at which the diameter is changing? So essentially, they're asking me find dx over dt. So I got to put this in terms of x. So this is going to be 4 pi. What's the radius in terms of x? Well, 1/2 x. And then squared. So this radius 1/2 x. That's what I put here. All right, so let's simplify this before we take the derivative, because you want to take a derivative of an easy problem, not a tough one. So this is 1/4 x squared. The 4's cancel out, so it's pi x squared. Now let's take the derivative of both sides with respect to t. ds over dt is equal to, remember, pi is just the constant, so 2 pi x times dx over dt. I need one more piece of information here. Let me read the problem again. I may have missed it. Oh, there it is. Find the rate at which the diameter decreases when the diameter is 10 centimeters. So find dx over dt when x equals 10. All right, there we go. Now we can do it. All right, let's plug in everything we know. ds over dt is going to be -1, 2 pi times 10 times dx over dt. Divide both sides by all this. So dx over dt is equal to -1 over 20 pi. I'm sure the back of the book will rationalize the denominator, but this is fine. And then you can just put it in your calculator to see what the decimal approximation is and make sure it matches the back of the book.
Professor, how
Yeah.
did you get ds over dt equals -1? Because I know originally it was
Oh, that's given to us.
in my textbook it says it's +1.
Yeah, it
I might
says
be
one.
looking at the wrong.
Oh, no. So it says if a snowball melts so that the surface area decreases at a rate of 1 square centimeters per minute. So if it's decreasing, it's negative. I
Okay,
should have
that
mentioned
makes sense. Okay, thank you.
So if it was increasing, for some reason, let's say the snowball is getting bigger, then it would be +1. So it's decreasing, so it's -1. I should have mentioned that, sorry. I did related rates with my morning calculus class at Cal State Fullerton last week, so I probably should have mentioned that to you as well.
One other question, why is the units in minutes, but you wrote it in seconds?
Because I'm used to saying seconds, this one is in minutes. It's supposed to be minutes, sorry.
Got it.
That's the only part, right? Right here, minutes. This part, right? Minute.
Yeah.
Okay.
When we answer these word problems, are our answers supposed to make sense to what we're supposed to be answering? Like -1 over 20 pi.
Yeah,
That's the one
so
to fix.
it makes sense because remember when the rate of change, in this case dx over dt, is the rate which the diameter is changing. It's negative because the diameter is decreasing, right? This snowball is melting. So therefore the surface area is decreasing at 1 square centimeters per minute. So if this snowball is decreasing, getting smaller and smaller and smaller, wouldn't the diameter getting smaller and smaller and smaller as well? So it makes sense that the diameter is decreasing as well. Not as fast because but it's decreasing. So in this case, you're watching a very boring video. This snowball over time is getting smaller, smaller, and smaller, and it's because it's melting. So the diameter is getting smaller and smaller and smaller as well, right? The rates are related. as the surface area changes, the length of the diameter changes as well.
Professor, what was that thing? Sorry, I missed it. You said it earlier. When it decreases, it's like a certain number. When it increases, a certain number, or something along those lines.
Well, if it's increasing, it's the rate of change is positive. If it's decreasing, the rate of change is going to be a negative number.
Oh, okay. Okay, thank you.
Yeah, I replaced the radius with diameter, so x is double the radius. So therefore, r is going to be 1/2 x here, because r equals 1/2 x. Why did I want x in there instead of r? Because the question says how fast is the diameter changing. So I need to figure out what dx over dt is, not dr over dt. Is that better? Is that better? All right, so let's do one more here before we take a break. Or you guys want to break now?
Do one more.
Can we-
All right, one more. Daniel, you actually want one more? Okay. This is number 16.
That's a negative, sir.
All right, this is a good one. Well, you might not agree. At noon, ship A is, let me just draw this here. All right, at noon, ship A is 150 kilometers west of ship B. Ship A is sailing east at 35 kilometers per hour. Ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? All right, so here's what's going on here. You have ship A, which is right here, right here. It's heading east at 35 kilometers per hour. So it's heading this way, okay? And ship B is heading that way. So notice as ship A is heading this way and ship B is heading that way, their distance are changing, okay? Are they getting further apart? Are they getting closer? Well, it depends where you're at as well, how the rate is changing. So their rates are constantly changing as this is going this way, but at the same time, this is going that way. So we're saying 4 hours later, we start at noon, 4 hours later at 4 p.m., at that particular moment, how fast is the distance between the two ships changing? That's the question. So what we're going to do is, let's write down the information that we have. We're given dx over dt. That's going to be negative 35. And I'll tell you why it's negative in a second. But right now, just trust me. dy over dt, hold on. dy over dt, that's going to be positive 25. So here's the reason why dx over dt is negative 35. I'm going to let this distance be, hold on. I'm trying to think of a good way to explain this. So the distance here, that's x. So as ship A is headed this way, right? What happens over this 4-hour video that you're watching? X is getting smaller and smaller and smaller, right? Because the distance from where ship A is to this spot, that's x. So as the ship is moving, it's making that line segment smaller and smaller and smaller. So therefore, the rate at which dx over dt has got to be negative because it's making that smaller. Whereas dy over dt, y is going to be this distance. As ship B is moving north, it's making line segment y larger and larger and larger. So therefore, dy over dt is positive 25 because it's increasing the line segment y at 25 units per second or whatever the units are. So does that make sense?
we're not looking at, we're not like thinking in terms of like quadrants, right? Like, because technically, if we're going from left to right, it would be getting larger. But
Yeah, you're not thinking XY axis. You're thinking how, because if you're in the C, well, what's the X axis? It's just where it's just the direction the ship is going. So in this case, the ship is it's closing in as time goes by. This X value is getting smaller and smaller and smaller because the ship is heading east, whereas Y is getting larger and larger and larger. So at first, their distance is like this, but then it's like this, then it's like that, then it's like that. You see how as X gets, first it's this distance, then X gets like this, then X gets like that, then it gets like that. X is getting smaller and smaller and smaller as the ship keeps moving, whereas Y keeps getting larger and larger and larger as time goes by. Does that make sense?
yeah, definitely. Thank you.
So arbitrarily, I'm going to make this my triangle right here on the, I'm going to create that as my triangle. So the question is, I need to form some sort of relationship here. Well, a lot of times these problems are going to use the Pythagorean theorem. So in this case, I'm going to say, how fast is the distance between the ships changing? We're going to call that distance S. So let's say the ship is here and here. S is going to be the distance between them. And the formula that I'm going to use is, hey, x squared plus y squared equals s squared. Now I'm going to take the derivative of both sides with respect to t. So 2x times dx over dt plus 2y times dy over dt equals 2s times ds over dt. Now, my goal is to figure out what ds over dt is, because that's this guy right here. I want to know how fast the distance between the ships are changing. So right now, my ship A is somewhere over here, and ship B would be somewhere over here. Now, I know what to plug in for dx over dt, which is negative 35. I know what to plug in for dy over dt, which is 25. But I don't know what to plug in for s right now. And I need to know what to plug in for y, and I need to know what to plug in for x. So we'll get to that in a second. Are you guys caught up writing? So we go off to the side and go back and look at the problem. They said 4 hours later at 4 p.m. Well, what will x be? Well, initially they start 150 kilometers apart. So therefore, 4 hours later, x is going to be 150 minus 4 times 35. I'll explain this in a second. So 4 times 140, which is 10. So here's what I did. Initially, the ships A and B, this x value is 150. But the ship A is heading east at 35 kilometers per hour. So if it's heading east 35 kilometers per hour, it's going to go 140 kilometers after 4 hours. So what's left of x? 10. 150 minus that 140. Now, what would y be? Well, y is easier. It's just 4 times 25 because it's just heading north at 25 kilometers per hour. So y would be 100. Does that make sense? I know I'm throwing a lot at you here on this call. So now what's S? Well, S is just S squared equals X squared plus Y squared. So S squared equals 10 squared plus 100 squared. So S squared will be 10,100. S is the square root of 10,100. Now I have the values that I want to plug in. So I have X, I have Y, and I have S. So going to the right side here, my main problem, I can go ahead and solve for ds over dt now. That's negative 700 plus 5,000 equals 2 times the square root of 10,100 times ds over dt. So ds over dt equals 4,100 over 2 times 10,100. Now I'm not going to bother rationalizing the denominator. What you could do is you just plug in your calculator and make sure it's the same decimal approximation as the back of the book. So in this case, DSTT, when you put in your calculator, you're going to get 21.39 kilometers per hour. So go ahead and finish writing this down, then I'll talk. Okay, so basically on this problem, what we're saying is at 4 p.m., which is 4 hours later after they start, ship A is going to be somewhere here, and ship B is going to be way up there. At that particular moment, let's say this is like way up here, like that, something like that. The distance is changing at 21.39 kilometers per hour. Now that's a pretty involved problem because you have to figure out all the x's and y's and all this stuff on the side. They're not all that complicated. Some of them are a little bit better. How many of you could have solved the problem? How many of you I lost you completely? All right, we'll do more. Yeah, I gotta come up with my own examples. This is not a good first theorem problem to do. Oh yeah, I should make an easier example for next semester, huh? To start with.
Maybe, yeah. That sounds like a better plan.
All right, let's take a break. I need a break too. We'll start at 4:35.